Jai Hind, friends. I am Yogeshwar Kahar from New Catholic Mission School, Jhaua. Today we start the chemistry lecture for 12th class student, and our topic is Corro's law. It's very important for you, so you easily memorize it. So the statement of Corro's law is the limiting molar conductivity, the limiting molar conductivity of any electrolytes light is any electrolyte to be equal the sum of limiting molar conductivity of cation and anion of the electrolyte. Clear? The Corro's law is the limiting molar conductivity of any electrolyte to be equal the sum of limiting molar conductivity of cation and anion of the electrolyte. So Corro's law use the determination of limiting molar conductivity. What is meaning of limiting conductivity? The molar conductivity is defined in infinite dilution, so it's called limiting molar conductivity. This involves its meaning is infinite dilution. Okay, so according to this law, the mathematical expression of Corro's law is limiting molar conductivity. We repeat, limiting molar conductivity is equal to the sum of limiting molar conductivity of cation and anion. So it's limiting molar conductivity of cation and its limiting molar conductivity of any electrolytes. Then this meaning is limiting molar conductivity for cation, then limiting molar conductivity for anion. Okay, so the Corro's law is the limiting molar conductivity of any electrolyte to be equal to the sum of limiting molar conductivity of cation and anion. Okay, again we take some example like that. We know the some electrolyte NaCl, CH3, COOH, etc. Okay, I remove it. So the Corro's law for the NaCl electrolyte is the limiting molar conductivity of Na plus ions plus the limiting molar conductivity of Cl minus ion. Okay, then again CH3, COOH is also weak electrolytes. This is strong electrolyte and this weak electrolytes. Okay, so the limiting molar conductivity of H plus ions plus limiting molar conductivity of CH3COO negative. Okay, you return some more examples for HCl, HCl, KCl, etc. for the Corro's law for HCl and KCl. Clear? Some more applications are there for Corro's law. Total 4 applications present we have. So we discuss one by one. So application of Corro's law. Okay. application of what is the CoRoS, CoRoS, CoRoS law. Okay, first is calculation of limiting molar conductivity for weak electrolyte through light, okay, with the help of strong electrolytes. Okay, then second application is calculations of degree of dissociation for weak electrolytes. Weak electrolyte. Then third application is calculation of dissociation constant of weak electrolyte. Relation of dissociation constant for weak electrolytes lights. Okay. Then fourth is determining the solubility of sparingly soluble solid. Okay, we have four applications for CoRoS law. First is calculation of limiting molar conductivity for weak electrolyte with the help of strong electrolytes. Then second is calculation of degree of dissociation for weak electrolytes. Then third is calculation of dissociation constant for weak electrolyte. And fourth is determining the solubility of sparingly soluble solid. We discuss one by one. First we take the calculation of limiting molar conductivity for weak electrolytes. Okay, suppose we think about the weak electrolytes. So we have one example. CH3COOH is a weak electrolyte. Okay, it's weak electrolyte. So we calculate the molar conductivity of weak electrolyte. So how I calculate it? First, I return the CoRoS law for weak electrolytes H plus and CH3COO negative. Okay, if I know the value of H plus, limiting molar conductivity of H plus ion, and limiting molar conductivity of acetate ion, so I calculate easily the limiting molar conductivity of acetic acid. So how I know it? So that we use some electrolyte, we take help of some electrolyte with the help of strong electrolytes. Okay, so we take some help strong electrolyte, suppose we want H plus ions, so we know that from HCl is a strong electrolyte, it's give H plus ions and Cl minus. It's not important for us because this negative ions, anions, not required for us. Then again we want CH3COO negative acetate ion, so I know some more strong electrolyte CH3COO Na, so it give Na plus acetate ion CH3COO minus. Okay, it's important for us. but Na plus and Cl minus it's not important for us. So we again take one more strong electrolyte NaCl, then it convert into Na plus, then Cl minus ions. Okay, done. So give equation 1, 2, 3. I want H plus ions and limiting molar conductivity for H plus ion and limiting molar conductivity of acetate ion. Okay, so I add the value of 1 and second limiting molar conductivity of HCl and CH3COONA and subtract the equation 3. So you add 1 and 1 plus 2 and subtract 2 equation 3. So what happened here? So your limiting molar conductivity CH3COOH is equal to HCl plus OCH3COONA plus NaCl. Okay, so it's minus. Then I put the value here. H plus ions is H plus Cl minus. Okay, then CH3COONA, the value of from equation 2, Na plus CH3COO negative. Okay, then minus. Then now I put the value of, so we use bracket Na plus Cl minus, its value of limiting molar conductivity of NaCl ions. Okay, now I multiply this minus into the bracket, so this Na plus limiting molar conductivity come in minus, plus minus also minus. Now I see here Na plus ions is minus and here positive, here minus, here positive. So remaining is, so it's equal to the limiting molar conductivity of weak electrolyte acetic acid is equal to remaining the limiting molar conductivity of H plus ions and this ions also remaining CH3COO negative ions. Okay, done. So you check it. Our answer is here. If you know the value of H plus ions, if you know about the HCl limiting molar conductivity and sodium acetate limiting conductivity and sodium chloride limiting molar conductivity, so you put the value of 3 terms and calculate the acetic acid molar conductivity. Okay, now we move in next application, but before we solve some numerical problem from our NCERT book. Okay, we have two examples, example 3.7 and 3.8. We start the solution of example 3.7 and 3.8. Okay, example 3.7. Okay, I read. You also open your book and check the page number 84, example 3.7. Calculate the limiting molar conductivity of for CaCl2 and MgSO4. Okay, from the data given in table 3.4. Okay, so I check this table. Okay, so the solution is, first I written this electrolyte from Colruyt's law. M, it means CaCl2 is equal to limiting molar conductivity of Ca2 plus ions and limiting molar conductivity of Cl minus ion. These two is moved on the molecular place. Okay, now I put the limiting molar conductivity of Ca2 plus ion is given in the table. Limiting molar conductivity of Ca2 plus ion is equal to 119.0, unit is Siemens centimeter square mole inverse. Okay, it's given in the question. One more, limiting molar conductivity of Cl ions. So it's Cl minus ion 76.3. Then Mg ions, limiting molar conductivity of Mg2 plus ions is 106.0. Then SO4, limiting molar conductivity is SO4 2 negative ions, we have 160.0. Okay, so now I calculate easily. Put the value of Ca2 plus ions. Where is Ca2 plus ions? 119.0. Okay, done. Then 2 into Cl minus, the molar conductivity of Cl minus 76.3. Okay, now solid 119.0 plus 3 to the 6, 6, 6, 12, 12 and 1, 14 and 1, 15. Okay, now add the value of both 0 and 152.6. Then 6, 9, 2, 11, 5, 6, 1, 7, 2. So 271.6 Siemens centimeter square mole inverse. It's the limiting molar conductivity of CaCl2 electrolytes. Okay, how I calculate? The question say calculate the limiting molar conductivity for CaCl2 and MgSO4. Okay, so some values are given in question. I written from the table. Okay, so according to Quadros law, I know that the limiting molar conductivity of CaCl2 is equal to the sum of limiting molar conductivity of Ca2 plus ions and Cl minus ions. Okay, so I put the value of Ca2 plus ion from here, then Cl minus ion from here. Okay, then solve and calculate the answer. Again, we want one more limiting molar conductivity for MgSO4. So I written MgSO4 in according to Quadros law is equal to Mg2 plus SO4 2 negative. Okay, now put the value of Mga2 plus, where is 106 plus 160. Okay, 0.0 is not applicable for us. 160, 106, then 662. So our answer is 266. Then we have already written here. Unit is Siemens centimeter square mole inverse. Okay, Siemens centimeter square mole inverse. Done. I think it's very easy example. 3.7. You calculate more like that for HCl, BaCl2, etc. Okay, and use the value. If you want the value of H plus ion, Cl minus is present here, Ba2 plus ions. So you check the table 3.4 from the NCERT book, page number 83. Okay, and our next example is 3.8. Okay, our next example is 3.8. Again, open your book and check the example 3.8. Limiting molar conductivity. Again, limiting molar conductivity for NaCl, HCl and sodium acetate NaAC are 126.4. So I written directly here. I have the value of NaCl is equal to 126.0. Then limiting molar conductivity for HCl is 425.9. Then sodium acetate NaAC. The meaning of NaAC is CH3COONA, sodium acetate. Okay, the value of limiting molar conductivity for sodium acetate 91.0 Siemens centimeter square mole inverse. Okay, I use this unit for all three limiting molar conductivity. Okay, now I want to calculate limiting molar conductivity of acetic acid. So how I calculate CH3COOH is equal to, I know that according to Colroth's law, H plus ions plus CH3COO negative ions. Okay, already I clear it. I want H plus ions, it's give this equations. Acetate ions give this equation 2. Okay, so I put here equation 1, equation 2 and equation 3. So we add equation 1 plus 2 and subtract equation 3. Okay, so acetic acid CH3COOH is equal to the equation 1 NaAC plus HCl and minus NaCl. Okay, put the value of limiting molar conductivity of sodium acetate 91.0 plus here 425.9, it's limiting molar conductivity for HCl, and minus NaCl, it's limiting molar conductivity of sodium chloride 126.0. Okay, 0.0. Okay, first we add 425.9, 91.0. So 9, 5, 1, 6, 11, 15. 51, 500, 16.9 minus 126.0. 516.9, 126.0. Subtract 9, 660 to 11 minus 2, 9, then 4 minus 1, 3. So our answer is 390.9. Okay, then unit is Siemens centimeter square mole inverse. It's limiting molar conductivity for acetic acid. Okay, I think it's very easy. One more time we check it. We use first application for solve this problem, example 3.8. Limiting molar, the example say calculate the weak electrolyte molar conductivity, limiting molar conductivity for weak electrolyte acetic acid with the help of this data. Okay, so I check, I want H plus ions concentration and CH3COO limiting molar conductivity. Okay, so we see here H plus ions give second equation, acetate ion give first equation. So I add 1 and 2 equation, and NaCl is not for work, so it's minus, so minus 3. We put the value of all data and get answer 390.9 Siemens centimeter square mole inverse. Okay, I think it's very easy. In next application 3, second, third and fourth we discuss in our next video. Thank you. Jai Hind, Jai Bharat.